Hello and welcome back to another LeetCode practice video where I practice code problems for interview preparation. So today I'm looking at LeetCode 55, the jump game. It's a medium greedy problem. So let's jump into this. You're given an integer array nums and you are initially positioned at the array's first index. And each element in the array represents the maximum jump length at that position. Return true if you can reach the last index or false otherwise. And it is guaranteed that all nums are, okay, they can be 0 or larger, meaning if they're 0, we can't jump forward from that position. And we have at least one element in there. Cool. Right, this reminds me a lot of a dynamic programming problem where I would just, compute all the reachable positions from a current position. So when I start at index 0, I know that I can reach position 1 and position 2, right? Jump length 1, jump length 2. And then when I go to the next index, I know that I can reach up to 1, 2, 3. Can I actually reach the last index already, and then I'm done. So just iterate over the array and store in another array how far I can get. So that would be one approach. Now for greedy, if we take a greedy approach, I guess what we can do is we can just remember how far we can actually get. And then we continue to iterate over the array, keeping in mind how far we can actually get. And if we identify another position from which we can jump even further, we update our how far we can get variable. And if our how far we can get variable is points to the last index or beyond, that means we can reach the end. So I think what we will have is an O of n time and O of one space solution with that. So where to use dynamic programming, it would be O of n space. I'm going to use this approach that I just outlined, which I guess is kind of greedy. So we should have something that tells us how far we can jump, right? Furthest jump, maybe. And we start at 0. And then we're just going to iterate over all of the indices and all of the jump length entries in our nums array. In nums like so. And now what we do is we need to update our furthest jump position, right? The furthest jump is, what is it? Well, it's the maximum of furthest jump and the current position plus how far we can jump from that position, right? So that's super simple, I suppose. And then in the end, we just return if furthest jump is, well, what do we need to check? Well, whether it can reach the end of the array. However, we need to do something else as well, because it could be, yeah, here in this case, second case, I should have gone through this before I started writing code. So in the second case, we can jump from the first index to this index where the 0 is, and from there we can't go anywhere. From the index I equals 1, we can jump 2 positions. So all of these positions land us at 0, and then we can't go any further. So at one point we will iterate over that position where furthest jump is smaller than the position, right? And in that case, we need to return false. That's what we need to do. Yeah, and otherwise we just return true, because if we're not returning false here because we can't go to the ith position, we will automatically abort. And once we reach the end of the array with our for loop, that means we were actually able to reach the end if this if statement didn't catch, right? So I think that should be it. That's all that is needed. Right, so let's run through the test cases. Okay, the 2 test cases pass. Let's submit it to see if it passes all of the tests. Nice. Okay, cool. Well, that concludes that problem. And with dynamic programming, we would have used over n space with this greedy approach where we just keep track of what is the furthest we can jump while we iterate over the array. We reduce the space complexity to constant space.